Hello my dear students, I welcome you to NEET World. So in this session we will be discussing the previous year questions of CUET UG chemistry. Okay, so this is particularly 15th June 2023 shift 1 paper. Okay, so let's start our session. And one more thing, before starting our session, just click on the like button so that it will be really boosting us to do more videos on this kind of content. Okay, so let's start our session with first question. Here we have the second most abundant element in alloy mish metal. Okay, so this is the alloy they have given. So in this, so mish metals generally contains what? The major composition is what? Lanthanides. Okay, and along with that some 5% of iron will be there. Okay, so almost 90 to 95% lanthanides and 5% copper, and also some traces of carbon, silicon, this kind of elements also present. Okay, so they are asking about second most. The first most is lanthanides, okay, and the second most is iron, I told you now. So what is the option here? So we have option number 1, that is iron is the correct answer for this question. Let's go to the next question. Correct increasing order of basic strength of the amines. So amines, when amines are given, so if the given amines contains aromatic and aliphatic amines, always remember aliphatic amines will be having more basic than this aromatic amines. Okay, why aromatic amines are less basic? Because let us say aniline here I have. So this is aniline. The lone pair electrons on aniline involves in the conjugation with the ring pi electrons. Therefore, its basic nature is lesser than this aliphatic amines. Okay, so here these lone pair electrons are free to donate, right? Therefore, its basic nature is more. Okay, I hope it is clear. Aliphatic amines are more basic, aromatic amines are less basic. Okay, now here tertiary amine is given, primary amine is given. How can we answer this kind of question? So remember, when ethyl groups are attached to the nitrogen, it is making ethyl amine, diethyl amine, triethyl amine, like that. Na? So in that case, remember 2 degree amine is more basic than 3 degree than 1 degree. Okay, so secondary amine is more basic than tertiary. In the given options, tertiary amine is not given. Okay, remove that. So 2 degree is more than 1 degree. So 2 degree is more than 1 degree. Okay, that is fine. After that, benzyl amine is more basic because aromatic ring is present, but the nitrogen lone pairs will not involve in conjugation here because there is no conjugative site. In between them, the CH methylene group is there. Therefore, there is no conjugation with the ring pi electron. So it shows basic nature more than the ammonia, and which is more than the aliphatic amine. Okay, I hope this is clear. Option number 1 is correct. Okay, so other options if you check, those are not correct. Okay, so let's go with, so what is the correct option? Only option number 1 is exact answer here. Okay, then let's move for the next question here. Given list 1, list 2, I match them. So from the list 1 and list 2, so if I want to check here, so let me scroll it up. So diamagnetic solid out of this. So if you look, find the oxidation state of these elements first. So for chromium here it is +4. It means electronic configuration for chromium is D5S1, 3D5 4S1 valency. When it is in +4, it is having D2. So 2 unpaired electrons are there. It cannot be a diamagnetic. Similarly here Fe3O4. Here Fe is in +2 and Fe is in +3. So unpaired electrons present in both of these things now. So that is also cannot be a diamagnetic substance. NaCl, yes, it can be a Na plus Cl minus. Both of them have fully filled electronic configuration, no unpaired electron is present. So NaCl is a diamagnetic substance. A3. So check any option with A3. Yes, only option B is having A3. Okay, remaining cannot be a diamagnetic because they have at least one unpaired electron. Based on that, simply we can solve this. Okay, remaining question options you can verify. Okay, then next, move for the next question. The reaction, a reaction takes in 30 minutes, okay, to complete 50%, and takes 45 minutes to complete 75% of the reaction. The order of the reaction is. So how can we do this? So if the reaction is first order, so let us say I have 100%. Okay, let me take here. So I have concentration of substrate as 100% initially. So now when it is taking the time required for 50% completion means 50% concentration will remains. Okay, so this is for 50%. Okay, how much time they mentioned? This is 30 minutes. Okay, now again 50% of this means it will become 25. So this is again T 50%. Okay, So for here to here, how much it is over? So it is over as T 75% reaction is done and 25% is remaining. Okay, so 1 T half, 2 T halves. So T 75% equals to 2 T halves. Okay, 2 T halves I can write. Okay, so but 2 T halves, how much they given? So as per this data, so 2 into 30 we should take, so it should be 60 minutes. Okay, but in the question they given T 75% equals to 45 minutes only. It means this is not satisfying the condition now. T 75, if we check from the given data, so we are getting 60 minutes. Okay, but actually if it is first order, it should be 45 minutes only. So this is not the first order reaction. So first option is incorrect. Okay, like this we need to check. Okay, now I will be giving you one direct formula. Okay, so T 75% of a reaction is equals to 4 power n minus 1 minus 1. Okay, 2 power n minus 1 and minus 1 T 50%. Okay, this is a formula you can use here. Okay, so this formula will not valid for first order reaction. That's why I given explanation specially separately for first order reaction. Okay, this is valid for other order reactions here. So let us say here n represents what? Order of the reaction, and let us take n equals to 0 order and we will verify this. So put the value of n as 0 here. So 4 power n is 0, 4 power minus 1 of minus 1 by 2 power n minus 1, n is 0, 2 power minus 1 minus 1 T 50%. I hope up to here it is clear. Okay, now 4 power minus 1. So I can write this as 1 by 4 minus 1 and 1 by 2 minus 1. Okay, into T 50%. Okay, I hope it is also clear. This is equals to T 75%. Right? There is no confusion now from this. Okay, so now T 75% equals to, so simplify this, 1 by 4 minus 1, it becomes minus 3 by 4, and like 1 by 2 minus 1, it is minus 1 by 2 T 50%. Okay, minus you can remove 2, 4 2 times. So T 75% equals to 3 by 2 times of T 50%. Okay, so 3 by 2 times of T 50%. So let us verify whether this ratio is correct or not. So as per the given data, T 50% is how much they mentioned? 30 minutes. Okay, and T 75% is how much they mentioned? T 75% mentioned as 45 minutes. So what is the ratio? 15 3s are 15 2s are. Yes, ratio is satisfied, 3 by 2 only. So it means, so what is the order of this reaction? It is 0 order reaction. You can go with option number 4. I hope it is clear without any confusions, right? So I hope everything is clear here. You can take this formula. This is a very important formula here. Okay, done. Let's move further. Which of the following haloalkanes react with aqueous KOH most easily? So write the structures. So this is 2-chlorobutane, this is 2-bromo-2-methyl propane, this is 2-bromobutane, and this is 1-bromobutane. So out of these three, which is more reactive? With aqueous KOH. So aqueous means what? See, that aqueous is a water, na? So water is a polar protic solvent. What is that? Polar protic solvent. Okay, so reaction is taking place in polar protic solvent with KOH, aqueous. So these favors, aqueous polar protic solvent favors SN1 reaction. Okay, remember this. So SN1 reaction is more favored in which case? So it will be favored when we have tertiary alkyl halides, right? So it means rate of reaction is more in tertiary alkyl halide. That's why option C is perfect answer for this. Okay, so if we remove this, we will be getting a tertiary carbocation which is highly stabilized, right, with these three methyl groups. Okay, by hyperconjugation and inductive effect. That's why this C option is accurate answer for this question. Okay, let's move further. So when a dilute aqueous solution of Ki, when a dilute aqueous solution of Ki is added to AgNO3, AgNO3 solution, the charge on the AgI colloidal particles formed will be, okay. So now what we have, so this is from adsorption like surface chemistry, so dilute solution of Ki, simple wait, okay, Ki and AgNO3 solution they have taken. So these forms which kind of solution? The charge on AgI colloidal solution. So AgI, so on these Ag plus adsorption takes place and forms positive colloid, okay. So what it will forms? So positive is a positive colloidal particles will be formed, okay. You can take this, okay. So on this surface AgI will be accumulated, adsorbed, okay. So let's move further. What is the name of this metal complex? So we have nickel with the tetra coordinated complex here. So 2 chlorines and 2 phenylphosphine is there, triphenylphosphine is there. So which comes first? Chlorine comes first. So while writing the name, so first write the name of the ligands in the square bracket and followed by name of the metal and indicate the oxidation state of metal in the parenthesis bracket, okay. So now here 2 chlorines are there, so I can say dichlorido, okay. So C comes first, that's why dichlorido, and the next triphenylphosphine it is, how many are there? 2. So already tri we are using that word triphenyl, so again we should not say triphenyl, okay, it makes us confused. So that's why when the name of the ligand is complex we should use bis, tris, like that, okay. So for 2 we should use bis, for 3 we should use tris, like that, for 4 tetrakis, like that. So what I can write? So dichlorido bis triphenyl phosphine, close the bracket, for the complex ligand. Next nickel, what is the oxidation state? This is oxidation state of, charge of triphenyl phosphine is 0, it is a neutral ligand, okay. So if it is 0, for chlorine each one is -1, we have 2 chlorines, so -2 and nickel will be +2. So in the bracket you represent nickel 2, that's it, this is our option. So first option is correct. Next one, identify the transition metal complex which are not octahedral in shape. Simple na, which are not in octahedral in shape. So by looking at the complexes itself we can say, so in order to show octahedral complex, in order to form octahedral geometry, it should be having 6 coordination number. What is the coordination number? 6. So here it is 6, it is octahedral, here it is having 4, so 4 means what? So tetrahedral or square planar, so this cannot form octahedral complex. The next, here it is having 6 coordination, it can form octahedral, here also 6 it can form octahedral, here it is 4, so this is square planar complex, platinum tetra coordinated complex are square planar, and this one is tetrahedral geometry. So I can go with A, B and E. So where do we have B, E? B, E, option B is correct. Okay, the second option is correct, which is having B and E. Hope it is clear, no confusions, right? Next, for the E cell, for a given cell is how much? So given E0 is given and they are asking about E cell. So these we can find from using Nernst equation, E cell equals to E0 cell minus 0.059 by n log concentration of products by concentration of reactants, right, to the power their coefficients. Let us see here. So what is the E0 cell? We will see. See, bromine is given and chlorine is given. So we know chlorine is more reactive than bromine, therefore chlorine can replace bromine from its solution. If it is NaBr, so Br will be replaced by this Cl and it will becomes NaCl. Okay, so this is based on the displacement reaction, the reactivity series. Okay, so now we will be having, if it is 2 Br minus, it will be forming Cl2, Cl minus and Br2. Okay, so during this process, how many electrons are exchanged here? 2. So N is 2. So I can say, so this is 2 Cl minus. Okay, so now E cell equals to, what is the E0 cell value? So as per this spontaneous reaction, so chlorine is undergoing what? Reduction, right? So I am writing E0 cell equals to So oxidation plus reduction we will write directly without any taking any other things, standard form we will take. So what happens, E naught, see chlorine is undergoing oxidation na Cl2 to reduction na Cl2 to Cl minus. So I am writing reduction half. Next plus E naught of bromine is undergoing oxidation of Br minus to Br2. Like this you can write. Okay. So what is the value of Cl2 to Cl minus? They mentioned Cl2 to Cl minus, they mentioned 1.36. Write it. Okay. Plus Br minus to Br. See they mentioned Br2 to Br minus. They given reduction potential, but I want to take oxidation potential only. So just take the negative value of that. So minus 1.09. Okay. That's it. So we are almost done. So if we remove this, so how much we are remaining with? So we are remaining with minus plus 0.27 electron volt. I mean volt. Okay, that will be the value. Okay, E cell. Okay, this is the value we got. Okay, so E naught cell value we got. So that is how much? 0.27. Okay. Okay, then next minus 0.09 by this concentration is not given here for products and reactants. You have to write Cl square, Cl minus square by concentration of Cl minus square by concentration of Br minus square. So that square 2 and this n value 2 both get cancelled. So here we can have to take 2. So log here Cl minus 2, Br minus 2. So if see log something is there, 2 is there, so this and this can be cancelled, right? And concentration is not mentioned, so we can say both are having same concentration, and overall log 1 will be 0, so this value will become 0, so E cell will be almost equals to 0.27. So what is the nearest option here we have? So here we have D 0.21, that is the only option we have very nearest value, so I am going with option number D. So this is the simplest way we can do this question. Okay, right, I am closing this. And then next 10th question, in which of the following molecules carbon atom marked with asterisk is steric center or chiral center? Yes, tell me which is chiral center here. So carbon should be attached with 4 different groups. If the carbon is attached with 4 different groups, then we can say it is chiral center. Okay, so here carbon is there, to that 4 different groups are there. Yes, this is chiral center. Here you can see hydrogen, hydrogen, both are same groups now. So the carbon with 2 same groups, no, it is not a chiral center. 4 carbon having tetravalency, so 4 valency should be satisfied by 4 different groups. So only first option is correct. And this one if you see, again methyl groups are same, so this is also not the one. Okay, so first option is the one correct, that's it. So option number D, again here they given 2 hydrogen atoms same, that is also incorrect. So only first option is correct for that. Okay, next, what about this? What about this question? Match the list 1 and list 2 based on their correct options. Okay, so now urease, what are the products? I think these are the enzymes and these are the products formed. So urease will be catalyzes urea to form ammonia and CO2. So A3, where do we have options? A3, yes. Okay, then next, what about invertase? Invertase will be giving, so sucrose converts into glucose plus fructose. So invertase is the enzyme we will be using. C2, so A3C2, where do we have? Yes, that's it. Okay, we got our option, first option is correct for this question, that's it. Okay, so remaining options you can verify. Okay, then next, let's move further. So option we got now here, so that is correct only. Then next, let us move further. Gel form, okay, list 1 again list 2 is given and we need to match them. So how do we match this? Okay, so let us try. So aerosol means what? It is a like dust we can say now. Okay, so D2. So from surface chemistry we have seen 2 questions, right? So you need to focus on the chapter surface chemistry. Should not skip any chapter for CUET. Even it is solid state, surface chemistry, all these chapters are there in the CUET exam, so should not skip. Okay, so just follow the syllabus they have provided. Okay, so D2. So D2, where do we have D2? Yes, D2 here. Okay, then next, Foam is wiped cream, B4 only here we have, and here also we have. Okay, then next emulsions. Okay, emulsion and gel. So gel contains cheese, curd, everything will be comes under gel. So A3. So fourth option is correct for this question. I hope it is also clear now. So no confusions, right? So let us move further. So D option is correct for this question. Again, list 1, list 2 is given. Matching is very important format of asking question in the CUET. I mean, they are focusing on this kind of questions more. Okay, this model is important. CD right is FeCO3 iron carbonate. Okay, so that's it. So let's B1, where do we have B1? Only option C is having B1, right? So like this, so when it comes to match the following, there is some advantages for us. So like at least by knowing 1 or 2 compounds or 1 or 2 options, so we can eliminate them based on that. There is a scope for that, right? So A1, B1 and C, A3 they given cholinite, A3, yes, correct. So malachite is 4, C4, yes, okay, correct one. The next, here the rate of reaction changes from here to here, okay, when concentration, okay, what is the order of reaction? Just write what is the basic rate equation. So we will be writing rate is directly proportional to concentration of substrate power its order, like whatever the order we will be writing here, right? So now I am removing this proportionality, I am writing K A power N. N represent order of the reaction. So this is for first reaction, let us say first order, like whatever they mentioned the concentration. So at concentration 1, rate is 1. At concentration 2, okay, let us say it is R2, okay, which is equals to K A, this is at concentration A2, okay, N. Okay, we need to find the value of N here. K can be cancelled because both are of same order reactions now. Okay, so now R1 value is how much? How much they given? 2.48 into 10 power minus 3. Okay, R2 is given 4.96 into 10 power minus 3. That's it. Okay, so initial concentration is given 0.6, final concentration 2, again 2.4. So now look into this 6 4 I can say. So we are getting 1 by 4, okay, and this 10 power minus 3 is cancelled. So this is again 2 times. So what is the final order we got? So here it is N I am taking, which is from here, both of them are having N. So 1 by 2 equals to 1 by 4 power N we got, right? So now I can write this as 2 power 1, 4 I can write, just I am taking these denominators, 4 power N I am writing, so 2 power 1, so 2 power 2n I am writing. So what is the value of 2n here? So 2n equals to, comparing this to 2n equals to 1, so n equals to 0.5 or 1 by 2. So we have option number C. Okay, so I hope it is clear without any confusions, right? Erase this. Okay, so you can go with option number C. Okay, ferric oxide in blast furnace, upper half is mainly reduced by what it is? CO, right? In the blast furnace it is CO. Okay, let's move further. Okay, the structures represent which are the particular kind of halides. So these are simple now. So I already mentioned in the GOC concepts. So we have discussed everything regarding this GOC part, which is important for this CUET, JEE, NEET, EAPCET, all this exam syllabus is, exam oriented. I have discussed everything regarding this GOC part. So now look, so whenever halogen is attached to a methylene group, so this C should be, if it is attached with a sp2 carbon like this, so we can say that is allylic position. Similarly, this one also is there now. This is, see, this carbon is attached to sp2 hybridized carbon which is having double bond. Okay, both are allylic halides, not alkyl halides, they are allylic halides. This option D is correct. Okay, which are the following will not undergo azo coupling? So which will not undergo azo coupling? So in order to show azo coupling reaction, see, that should react with the diazone, like benzene diazonium chloride, like this. Okay, so it should react with this thing. Okay, in order to react with this, so there should be high electron density on them. So it means electron releasing group containing benzenes will react with this. So aniline can react, phenol and anisole also, but not nitrobenzene, because nitrobenzene is electron deficient. I mean, nitro group will withdraw the electrons, therefore it will won't show reaction with this diazonium chloride. Therefore reaction is not possible, azo coupling reaction is not possible in option D. You can choose D as an option. Okay, the dissociation, degree of dissociation when molar conductivity of X at its concentration C is 24.14 and its limiting molar conductivity is given. So what is its degree of dissociation? So simple relation we have now, alpha equals to degree of dissociation equals to molar concentration, okay, by limiting molar concentration, molar conductivity by limiting molar conductivity, sorry. So at concentration C, this is a molar conductivity, okay, and this is a limiting molar conductivity. Just take the ratio of those two, 24.14, 48.28, that's it. So this is 1/2. So we have option number 2, that's it. So this is the option, this is the correct answer for this question.